Hello everyone and welcome to Docker Community All Hands number 5. My name is Mohammad-Ali and I'm going to talk about Node.js CI/CD pipelines today. So we're going to talk about how to get through all the different stages of a pipeline. We want to talk about how to build our application, how to test it, and at the end how to publish it in a pipeline, continuous integration and continuous delivery pipeline. First of all, some introduction about myself and about the presentation. So I'm a software engineer by the day. I'm a Docker user since 2015. At the time, Docker was 2 years old when we started using it, and I'm a community leader of Switzerland. So I'm the organizer of the Zurich community in Switzerland. If you have any questions, you can tweet me at Mohammad-Ali A'RÂBI. So I have two other Twitter accounts as well for two other languages, one in Persian and one in German. So this is Mohammad-Ali English. And everywhere else, my handle is A'RÂBI. You can contact me there basically. Today's presentation would be about Node.js and Docker basically. So we have a Node.js project backend written in TypeScript. We want to create a Docker image that has this Node.js executable, and we want to have this image in the production. So the image should be production ready. We're going to talk about how we have to build this image through a CI/CD pipeline. So the ingredients. Let's assume we have Node.js with TypeScript, which is now very common. Express.js as a web framework, so it doesn't really matter which framework do you use, but let's assume that we use Express. MongoDB as a database. A testing framework doesn't matter, still Jasmine, just Docker Compose, we will get to it later, and GitLab CI. So we can do most of these things with any other CI tool, but I'm going to use GitLab CI because I'm more familiar with it. But there will be not much code in the slides, so you can recreate all of these steps with any other CI tool. So the building phase would be three phases. First of all, you want to you have a TypeScript code. At some point, you want to transpile it into JavaScript, but before that, you might have some stuff that you want to do to add to this TypeScript code. So, for example, we have in one of our projects, we have a framework called SOA that creates the express route. So we don't manually write the express route. This framework builds it for us, and the output is TypeScript. In another project, we create a JSON file based on the type data that we have in our code, and we use it in production. So that's also something that we have to generate before we compile our code. This phase I call pre-transpile. So this is the jobs that you have to run before you want to transpile your code into JavaScript. Then the next phase would be creating an application. Make your TypeScript JavaScript. So first you transpile it. You might want to minify it because you're going to production. You want to uglify it, package all your JavaScript files together, or make it binary. So in some cases you want to attach the Node.js runtime into your JavaScript application and have the whole application as one file, and then you can run it in any environment. Then the next stage would be to create the Docker image based on this binary that you have created. So usually you put it into Alpine, or if it's a binary that doesn't need anything else, then you can put it solely in a vacant Docker image and it starts from the scratch. We will get to these parts later. The build steps that we want to talk about are these three. So we created a package JSON commands or scripts that build the pre-transpile stuff, the transpile itself, and then a third one that is build production. So we have separated this second phase into two commands. First of all, we transpile it into JavaScript, and the second one is production making. So we package them together or minify them. And the last job or last command that we have created in our package JSON would be Docker build. So we just put it there as an extra command so that the developer doesn't have to rewrite the whole command every time. So we can introduce these commands in our package JSON and use them later. The package JSON will look something like this. Yeah, so for example, we wanted to build the routes in our So we wanted to build the routes in our project. In the same project, we also had a Swaggle builder. So this library would allow us to create a Swagger JSON or an Open API specification, as it's now called. So we wanted to run these two jobs before we transpile into JavaScript. We have a transpile job that transpiles with TypeScript compiler. Then we have the prod build, which uses Webpack and PKG. So basically Webpack minifies, uglifies the code, and PKG packs them all together into one file. Or not, I think Webpack packaged them all together and PKG makes a binder out of it, if I'm not wrong, yes. So the next one would be Docker build. So we just build based on our root, and then we just add the tag to it. And the next one is publish Docker. So this is not really a build anymore, but we want to push our image to a registry. That's the other phase that we want to do. The Docker file we have in our project would look something like this: a two-step, two-stage build. To be exact, we use Node.js version 16 as the base image. This is just an example. Usually we create our own images with all the tools that we need for a successful build of our project. We put this image into our own private registry so that the CI/CD pipeline doesn't have to download it every time, or if it downloads it, it's then not too far away, it's in the local. We basically do npm install, we do all these different phases of build, and then we make this output a binary, make it executable. And then we copy this binary to the other one, to the next stage, so we don't want to have all this build information in our Docker. The end result would be a smaller Docker with only the production information. And then finally, we want to have a GitLab CI job that builds the Docker image. So we have this stage of build. We use this Docker image that has Docker and Node installed in it. So here we are using Docker in Docker. That is a thing in GitLab CI. So usually when you are running your CI job, the job is running inside the Docker container. But because here we are using Docker build, we want to use Docker in another Docker container. This is why it's called Docker in Docker. To do that, we have to add this service into our job. The full documentation is linked at the end of the slides. And here we log into our Docker account. Basically, you can use another registry, and then this command would look a bit different. You have to enter the registry's URL as well. And then we build and publish our Docker image, basically. So this would be easy if you had no tests. So this is one job CI pipeline with no extra things, but usually you want to test your application before you publish your image. This is why we get to this phase, testing. So let's assume you have an application which is somewhat complicated. We used in one of our applications MongoDB driver, and because we were using transactions, we had to connect it to a full MongoDB replica set. So transactions are supported only in replica sets, and we wanted to test this using a full setup. So what did we do? We created a Docker Compose file with the Node.js image with all the tests inside, and 3 replica sets, 3 MongoDB containers in it. So 1 primary, 1 secondary, and 1 arbiter. We put them all into one package Docker Compose, and then whenever we wanted to test them, we would test this code against all these 3 instances of MongoDB. There are 2 advantages of doing this. One is that you don't have to rely on an external service. You just create all your MongoDB instances locally, and then if you have Docker in Docker in your CI/CD pipeline, you can just run the same command in pipeline and be done with it. So you just have to make sure Docker is available and Docker Compose is installed, and then you just run the test the same way you're running in your local machine. So, for example, we would want to create this extra package JSON command, Docker Compose up, and then you want to see what is the exit code from this one container that you have. You can put this into your pipeline. So now your pipeline is divided into multiple jobs. First, you want to do this build tree. This is why we have separated it from the beginning, because your tests still need this preliminary job. Your tests still need this route to be generated and other stuff. Then after this thing is generated, you can use the end result to test your environment, again using Docker and Docker in your CI/CD pipeline. And then after all the tests are done, you know that everything's fine, then you can create your Docker image, the next stage. And then after you have created your Docker image, you would want to deploy it to production directly. So, or deploy it to another testing environment. This is where this 4th thing comes in, and we would want to talk about it in a bit. Before that, so these integration tests is usually not the only thing you test in your CI/CD pipeline. We usually have a lot more jobs. We test the code format. We use ESLint now. A commit linter, so the commits should have a very specific format. Start with this, tab one line here, things like that, and we can lint them in the CI/CD pipeline, and before every other test, so you can just fail the whole pipeline if the commit message is not fine. You would want to test the coverage of your tests. So if someone's contributing to the project, you want to make sure that every new feature that is added is also tested. You can do it with Jest out of the box, or you can create this coverage logs or reports, and then you pass them to the next stage and then check them with a Python or JavaScript file code step. So the next one would be dependency check. We usually check our code for dependency rules. For example, we don't want to have dependencies to the test files because the test files are not brought to the production. And the last thing we usually check is package log check, which is we check if someone changed the package JSON, they have installed it, and then they committed the package log as well. So the way we do it is, for example, we check the versions that the versions should match, and the packages and their versions also should match in package JSON package log. These are the few things that we check all the time in our CI/CD pipeline. You probably have more stuff, and for example, if you use Docker, if you use GitLab CI, there are also some tests that GitLab CI's the auto DevOps have out of the box. You can add them to your project, or on GitHub you have different security jobs and stuff like that. Okay, we're almost there. We are going to the last phase, publishing. So what does publish mean? So we still have different stages for publishing, different things we can do. First of all is the Docker image that you want to put into a registry, be it Docker Hub or GitLab's Docker registry or something like that. Then you want to create a preview environment. So GitLab, for example, has this feature that you can create an environment. You have another service that runs Kubernetes, and then you put your freshly built image into that environment, and then you can see and test it manually. You can run it against a UI or something. So after you put your newly built code into a preview environment, you can run a few checks against them. You can check them manually, for example. And then after everything is fine, you can create a rollout. So you say, okay, now all the jobs are green. We want to deploy this thing to our production servers, or we want to gradually deploy this into our different server nodes in Kubernetes, for example. So these all need extra talks to cover in full, but to give you an idea of what can the whole pipeline look like. And some other tips for you when you're creating the pipeline. First of all, you can save more time. So for example, in our Docker build, we have created this two-stage build, and we had installed all the dependencies. We did all the different stages of build in just there. You could do them outside. You could do the installation at the very beginning and then share these results, share the package.json folder throughout your pipeline. You could cache them, and then other jobs of your pipeline could use it. You could also do this with build. You could do the different stages of build in different jobs, and you could depend on that, just those jobs, depending on what you were doing next. Test away. So yeah, so the more tests you have in your pipeline, the less things can go wrong in your production. So don't be shy. Test at any test. You could later, if they don't have many, if they don't have much added value, then you can retire them later. Fail fast. So you would want to fail the whole pipeline pretty fast. So if you have some jobs that don't depend on other things and they are really fast to perform, you could put them at the beginning of your pipeline. In the GitLab CI, for example, you can create this dependency graph and then say which jobs are dependent on which other jobs, and the jobs that don't depend on any other jobs will be running first. So that's also it also doesn't depend on the stage, so you can run one job from the latest stage, but that job doesn't have to depend on any other things. Parallelize. You can still, again with the directed acyclic graphs that you have in GitLab CI, you can parallelize your jobs. The jobs that don't depend on each other can run in parallel to make your pipeline faster. And you would want to keep the whole pipeline's runtime under 10 minutes, because then if it's more than that, it's too long. You miss one semicolon, or I don't know, one tiny bit, and then you have to wait for half an hour to fail and try again. And you could split your CI/CD pipelines config into multiple files, so you can have one file for example, to build, another for deployment, and so you don't end up with a very huge file that you cannot maintain anymore. So these are a few tips. An extra tip which is not listed here, you can use a private image registry, because first of all, if you use your own images, it's more secure, and then you don't depend on varied external environment that Docker Hub has, for example, because the image that you're relying on might change and have breaking changes. And then if your image is stored locally, I mean, for example, if you have your own Docker GitLab CI instance and GitLab instance, if they are in the same network, then it would be faster. If you have to download things from Docker Hub every time, then it would make your whole pipeline slower. And I will put this slides with more material on these two repositories, both in GitHub and GitLab, because I want to have two different CI configurations there, and then you can access them later. I will add more stuff over time, but at the time of the presentation, at least the slides will be available, because you want to click on some stuff later. And the things you want to click on are some external resources for learning more about the whole CI/CD pipeline. GitLab CI's documentation on Docker and Docker. The environments, the feature that allows you to test your setup, test your newly added feature before you merge it to master. Multi-stage builds from Docker, and we had 2 talks in our Docker community that were about Docker image optimization and the security. So first one deals with reducing the size of your image, and the second one is more about how to make your image secure. That was it. Thank you for your attention. If you have any other questions, please contact me through any of these means that is shown in the screen. Thank you, and have a nice rest of the day.